Have you ever wondered how batteries work and how they are charged? It's a question that might pop up as you rely on these clever devices to power your everyday life. From your mobile phone to your car, batteries are everywhere, silently providing the energy we need to go about our day. Batteries are fascinating devices that store electrical energy through chemical reactions. They come in two main types. First, we have primary batteries. These are the ones you buy at the store, use once, and then discard. They're also known as non-rechargeable batteries. Then we have secondary batteries, which are rechargeable. You'll find these in your laptop, your electric car, or even in large-scale energy storage systems. They can be charged up, used, and then recharged again, over and over. Batteries can be connected in different ways too, to manipulate their output. When we connect batteries in series, we increase the voltage. But if we connect them in parallel, we increase the current. So, if batteries are so essential to our daily lives, how do they actually work? The inner workings of a battery might seem complex, but they're actually quite straightforward. At the heart of every battery are three key components: the anode, the cathode, and the electrolyte. The anode and cathode are electrodes, and they function as the battery's terminals. The anode is the negative side, while the cathode is the positive side. The electrolyte is a substance that sits between these two electrodes. Now let's dive into the chemical process that converts chemical energy into electrical energy. This process is known as an electrochemical reaction. When a battery is in use, the anode starts to undergo oxidation, a process where it loses electrons. These electrons, eager to find a new home, start to move towards the cathode. However, they can't just directly jump over to the cathode due to the presence of the electrolyte. This electrolyte is cleverly designed to bar the path of these electrons, forcing them to take a detour. This detour leads the electrons to move through a connected device, such as a flashlight or a smartphone. As the electrons flow through the device, they generate an electric current, powering the device. Meanwhile, at the cathode, a process called reduction is happening. Reduction is simply the gain of electrons. So, as the cathode receives the electrons that have made their way through the device, it undergoes reduction. Now remember, this entire process is a loop. The electrons are continuously flowing from the anode through the device and finally to the cathode. This flow of electrons or current will persist until the chemical energy in the anode is depleted. When that happens, your battery runs out of juice and your device turns off. But don't worry, not all hope is lost for our little battery. If it's a rechargeable type, we can reverse this process and breathe new life into it. Now that we know how a battery works, you might be wondering, how do we recharge it? Recharging a battery involves reversing the chemical reaction that occurs when it's in use. This might sound a bit complicated, but stick with me and we'll make sense of it together. When you're using a battery, it's in a state of discharge. The energy stored within it is being converted into electricity to power your device. This happens through a chemical reaction inside the battery, where electrons flow from the negative terminal to the positive terminal, creating an electrical current. But what happens when your battery runs out of juice? That's where recharging comes in. Recharging is essentially just the reverse of the discharging process. Instead of the electrons flowing from the negative terminal to the positive terminal, the flow is reversed. This reversal is achieved by connecting your battery to an external power source. This could be a wall socket, a USB port, or even a solar panel. The external power source drives the electrons back from the positive terminal to the negative terminal, reversing the chemical reaction. As the electrons flow back, they bring with them the energy that had been used up. This energy is then stored in the battery, ready to be used again. This is why your battery gets full when you recharge it. It's storing up energy for future use. This recharging process isn't instant, though. It takes time for the electrons to flow back and for the energy to be stored. The exact time will depend on the type of battery and the power of the external source, but generally the higher the power of the source, the faster the recharge. So that's the basics of how recharging works. It's all about reversing the chemical reaction, driving the electrons back to the negative terminal, and storing energy for future use. Recharging a battery seems simple, doesn't it? But what happens when you connect batteries in series or parallel? Connecting batteries in different ways can change their overall voltage and current. When batteries are arranged in a series, the voltage increases. This is because in a series connection, the total voltage is the sum of the voltages of each battery. Therefore, if you have 3 batteries each with a voltage of 2 volts, your total voltage will be 6 volts. On the other hand, when batteries are connected in parallel, the current increases. This is because in a parallel connection, the total current is the sum of the currents of each battery. So if you have 3 batteries each with a current of 2 ampere hours, your total current will be 6 ampere hours. However, it's important to remember that you should use batteries of the same voltage and similar amp-hour ratings when connecting them in series or parallel. This is because mismatched batteries can lead to uneven charging or discharging, which can shorten battery life or even cause safety issues. So, as you can see, the way you connect your batteries can greatly affect their performance. In today's discussion, we've seen how batteries work and how they're charged. We started off by understanding that batteries store electrical energy through chemical reactions, acting as powerhouses in our everyday devices. We then dove deeper into the working mechanisms, highlighting how primary and secondary types of batteries function, and the distinction between non-rechargeable and rechargeable ones. We further explored the fascinating process of how batteries are charged, a vital cycle that ensures the continuous supply of power. This understanding is key to optimal battery use and extends the life of our devices. Our journey didn't stop there. We delved into the intriguing world of series and parallel connections. We learned that connecting batteries in series increases voltage, while a parallel connection boosts current. It's crucial to remember that using batteries of the same voltage and similar amp-hour ratings is essential when making these connections. And that's the fascinating world of batteries, a world that's a lot more complex and interesting than you might have thought.